Okay, I'm going to do graphically the second problem here first. I want you to see on the picture how this one works. So we've got a somewhat more complicated function that we're looking at, the limit of, and it's curve instead of a straight line, so that makes things a little more interesting, a lot more interesting. But this is our function here, it's 0.2x cubed. So I got a cubic function, flattened out some by the 0.2, but we're looking at the limit as x approaches 2. So that's my a value, that's the point that I'm looking at, is right around 2. What are the values of f of x? So, and it's a nice smooth function here, continuous function, so if x was equal to 2, I would get 0.2 times 8, which is 1.6. So that's the output there, that is f of 2, and that is the limit here, because if I'm in a neighborhood of 2, I'm going to get stuff close to the 1.6. You can see that here. So that's my capital L here is 1.6. And right now I'm looking at a broad epsilon. My epsilon value is 0.4. So the width here is 0.4 units above or below the 1.6. It's not too hard to stay within that big range of values. So I have a red band down here around 2, a neighborhood around 2 that seems to stay within that little band, meaning that anything in here, the value of f of x is going to stay within the purple band here, but there's a big complicated expression for how that d works, and we're going to work through the inequalities to see how I came up with this, but that works pretty well no matter what epsilon is. Even if I make this smaller, my delta, which is a function of epsilon here, depends on epsilon, is going to shrink down also, so that I'm still within that range. So if we take a closer look at that, we're still right around 1.6, and the values when I'm within this band are going to be close to that, are going the f of x when x is close to 2 is still going to be within this little band around 1.6. So this is working the way that it should, but coming up with this great big thing is the key to this proof. Now whenever x is close to 2 within this weird looking distance delta, f of x is close to 1.6. That's what we're looking for.